All right, this section is on limits. Limits is something that starts at the very beginning of calculus. It's kind of the basis for some of the things that happen at the beginning of calculus. A limit describes what happens to the y values as your function approaches a certain x value. So as you come closer and closer to an x, so it doesn't matter what x is, let's say x is 2. As you come closer and closer from the left, so from numbers below 2, what happens to your y values? Do they get closer and closer to a certain number? What happens as you approach 2 from the right? Do your y values approach a certain number? If they do, if they approach that number from both sides, that is considered the limit. Most of the time, the limit is the y value, but not always. So it's like if you're looking for a pattern, or we get closer and closer to this, or we get closer and closer to 5. It doesn't matter if you ever reach 5, but does it look like that's where we're getting closer and closer? So first we're going to do limits from graphs, because that kind of defines what's happening with the limit. So we're going to follow the curve towards the x value from the left. So like here, we're going to come closer to -1. Let's say here's -1 right here. We're going to approach from the left and see what happens to our y values to get closer and closer to a certain number. Then we look backwards from the right. As we come back from the right, do our y values get closer and closer to a certain number? If they do, if they get the same number from both sides, that is our limit. Now those two things have names. They're called one-sided limits. Here, if you can read this, notice that says the limit as x approaches c, and see that negative sign? That's up kind of as in the exponent on c. That if there's a minus after the number, that means you're approaching from the left. Here, notice there's a plus sign after the number. That means you approach from the right. So like here, we're saying this is the limit as x approaches -1 from the left. Here, this is the limit as x approaches -1 from the right. Then when there's no plus or minus, that means the overall limit at that point. Well, that's where you look and say, is the limit from the left match the limit from the right? If it does, then that is your limit. So let's look at that one. So we have this graph to work with here. So we approach -1 from the left. So we start from the left. Here's -1 right here. As our x values come back here from the left, as we get closer and closer to -1, our x values are about 2, 2.5. Looks like they're getting closer and closer to 3. So the limit from the left is 3. Then the limit as x approaches -1 from the right. So now we start from the right side and come backwards towards here, x equals -1. Well, there it looks like our y values get closer and closer to 3. Since our limit from the left was 3 and our limit from the right was 3, our limit is 3. Or this one. This says the limit as x approaches -3 from the left. So we find where x equals -3. Well, 1, 2, 3, that's right here. So as we approach -3 from the left, so as we come here from the left towards -3, looks like our y values get closer and closer to 1. If we come backwards from the right, so we come backwards here from the right, as we get closer and closer to here where x equals -3, looks like our y values get closer and closer to 1. So our limit as x approaches -3 is 1. No problem, pretty basic. Now let's look at this one on the bottom. Now here, that says the limit as x approaches 1 from the left. So here's 1 right here as we approach from the left. So we follow that curve from the left. Looks like our y values get closer and closer to 2. So our limit as x approaches 1 from the left is 2. Now we come backwards from the right. So we come back from here, we come backwards from the right. Well, as we get closer and closer to 1, notice our y value is going to get closer and closer to -1. Now they don't reach -1 because see there's an open circle there, but that doesn't matter. All we care about is they're getting close. They're going to be so close it's going to be like -1.0001. Well, that's almost 1. So the limit from the left is a -1. Now, as we said before, you want the limit from the left to match the limit from the right. Well, here they don't. So this limit does not exist. Okay, let's look at this other graph now. Same thing. Up here we have the limit as x approaches -2 from the left. Well, we find -2, that's right here. As we come from the left to right, our y values get closer and closer to 1. So our limit from the left is 1. As we come from the right, here that's the limit as x approaches -2 from the right. Well, as we come backwards from the right, looks like our y values get closer and closer and closer to 1. So, since the limit from the left is 1, the limit from the right is 1, our limit at -2 is 1. Let's look at this one. The limit as x approaches as x approaches +2 from the left. Well, here's +2 right here. As we approach from the left, we're getting closer and closer to 1. Now notice there's an open circle there, so it doesn't actually reach 1. Actually, at that point, it jumps up to 2. But again, with limits, we don't care what the actual value is. All we care about here, our values are getting closer and closer and closer and closer to 1. Our limit from the right. So this is the limit as x approaches 2 from the right. Well, if we come backwards from the right, still our y values get closer and closer to 1. So our limit is 1. Now, if I actually asked you to find g of 2, remember this is function notation. It says when x equals 2, what's y? Well, if you look at the graph, when x equals 2, y is actually 2, because that's where the point's at. But again, it doesn't matter. The limit and the value at that point don't have to be the same. Down here, the limit as x approaches 0. Here, the limit as x approaches 0 from the left. Well, here's 0 is the y-axis here. As we approach from the left, we're going to go down and down and down. You could say does not exist. In fact, early you say does not exist. It's a little more descriptive to say, it kind of describes what happened at the graph if I say the limit is -infinity, because it's just going to keep going down. Now here, the limit as x approaches 0 from the right. Well, if we come backwards from the right to there, we're still headed down, down, down. So it's -infinity from the right. So since they're the same, it's -infinity. Again, early, like if you looked in a book, it would say the limit does not exist, and that's true. But if you were describing this graph to somebody, if I told you the limit from the left and the limit from the right was -infinity, wouldn't you have a picture in your mind about what the graph is doing right there? That, you know, it's going to die right there. So that's how you do limits from graphs.